Hello everyone, here we are, Robin the Sudoku guy with another tutorial number 69. Now this is a unique tutorial because I had one of my players write to me in an email asking that I do a puzzle that she was having trouble with. And I looked at it and I thought, yeah, I'm going to do that as a tutorial because there's so much we can teach you. Her name was Santosh Damuller. I'm not sure which country they're from, but anyway, thank you, Santosh, for giving me this opportunity to show a difficult puzzle. And I have to thank also my sweetheart, Catherine, because she did this puzzle and she found something before I did. So here we go. First thing that something stands out straight away, I see we have a top, a 1 and a 1, and this becomes a 1. If that is a 1, let's look down. There's a 1 here, so we can have a small 1 here and a small 1 there. So we're off the way. What about 2s? There's only 1 2, but because of this rectangle here, that's from another lesson earlier, this could be a 2 and this could be 2. And it can go in 2 cells, so we put it in. 3s, the 3s are there. 4, only 1 4. Doing the cross meet doesn't help as much. 5, no 5s, no 6s. 7s doesn't help much. 8s, the 8s are there. 9s, here, look at this. If I take this 9, we're doing the cross meet system. Take this 9 across here. We're looking at this block in here that doesn't have a 9. Take this 9 and go up there. What do we finish up with? We've got a 9 that can go here and there. Now, what does that mean? Middle, bottom, and 9 can be there or there. It can go in 2 cells, we'll put it in. Okay, well that was neat using the cross meet system. Now let's go on to this section here. Anything there? 2s, yes, we have it. 1s, no. 2s, 2, top, middle, bottom. There's a 2 down here, so we can have a 2 here and a 2 there. Okay, 3s, no 3s. 4s, let's look at this. Here's a cross, we can do a cross meet with a 4. Cross here in this block, cross down in here, which means that this is a possible 4 and this is a possible 4. Now, using LCR, center, left, right, this is a 4 in the center, left. These 2 could be a 4, so we can put it in because there's only 2 cells. It can go. Fantastic. 4, 5, no 5, no 6. It's 1, 6, only 6. That's the only 6 in the whole puzzle. Oh boy. 7 crossing for the 7s. No. 8s are all there. 9s. Let's have a look at the 9s. If I go across here for this block in here, if I go across here, we could have a 9 here because of this 9 coming down here. We have 9 could go in 2 spots, so let's do that. And while I'm at that, keeping that in mind, this 9 coming down to this block would mean also that this could be a 9 and that could be a 9. So we have a form of a mallet there. Anyway, now let's go down to here. We've got all the ones are there. Well, we have a middle, we have a top, we have a 1, it can go there. We can have a 1 can go there because there's a 1 up there. 2s, and they're there. 3s are there. 4s, no luck. 5s. Well, look at this. Top, bottom, we could have a 5 here, and we could have a 5 there. Okay, 6, no 6s, 7s are there. 8s, no 9s. Okay, we'll come down in here. What do we see? 1s are done. 2, 2s are done. 3. Well, we can have 3s here. 1, 2, and 3. I'm going to leave it because it goes in 3 spots. We want to just go for 2 spots for the time being. 4s. Well, we've got 4s already. 5s. That doesn't help us much. 6s. Only 1 6. 7s. 8s are down there. 9s. Okay. Not much luck with the 9s other than what we've got up here. We could have some 9s down here, but too many. Let's go look at this here. We have 1s are done, 2s possible there, 3s we got a right and the left. We have a possible 3 here and a possible 3 there. Good. 4s, no luck, no 4s at all. Okay, 5s, 6s, no luck, 7s are there, 8s are there, 9s we've done. Okay, over here. Now let's look at this one. 1s, Done. 2s. Well, we've got possibilities in there. Could be there, and there. Too many spots. We wanted to put it in 2 cells if we can. We're using the Snyder method of notation to begin with anyway. 3s, 4s, no, 5s, no, 6s, 7s, 7s, 8s, they're all there, 9s, not much luck with that. Okay, so now we get to the stage where I'm looking for a row, a column, or a block with just 3 empty cells. I don't see anything with 2 empty cells, so we'll go with 3 empty cells. Let's have a look at this now. Where do we have any places where there's only 3 empty cells? Yes, there's one right here. 3, 3, 4, and a 6. 3, 4, and a 6 is there. So we can't have a. So that's a 3, 6. There's a 4 over there. Here we have a 3 and a 6. There's a 6 here, so that becomes a 3, 4. And here we have, what have we got done in here? We have a 3 here, so we have a 4, 6. Well, that's all by value of cells. In other words, 2 by value of numbers, so that it's only 2 numbers in there. That's good. That's a good sign. Okay, anything else where there's only 3? Yes, there's one here. 1, 2, 3. The numbers missing there are 1, 2, 3, 4, 6, and 9. Well, there's a 6 right in here, so this will be a 4, 9. Here we have a 4, 6, and 9. 4, 6, and 9. And over here we can have a 4, 6, and 9. But I just noticed something. Whoopee! This is neat to notice. Watch this. See this 4 here? That cannot be a 4. Because using LCR, center, left, right, these must be a 4. That cannot be a 4 because there's going to be a 4 in there. So that means we can get rid of that 4. That's a neat little trick. Okay, good. That's helps. Anything we can get rid of, the better. Okay, any other places where there's only 3? Okay, 1, 2, then 1, 2, 3. Okay, here we have 1, 2, 3 there. 4, 5, 9. Here we have a 4, so this would be a 5, 9. Okay, now here's a block that's only got 3 left. Let's feel what are the numbers left. There's a 4, 6, and a 9. Looking up and down, this would be a 4, 6, 9, and this would be also a 4, 6, 9. Now we've done the cells where in a row, column, or block where there's only basically 3 empty cells. Now we have to go to look for 4. Now this is the stage where you have a choice. You can try and put all the possible numbers in where there's only 4 cells, but it becomes a lot of time and a lot of work and pretty messy. So if you've got a computer, some of the computers you just hit a button and they put all the possible numbers in there for you. Now, because today it's a big puzzle, I'm going to be right back in a second and do what a computer does, put all the possible numbers in. And you know, after all that time, we just only got 1 number. It's not an easy puzzle. So what do we do now? I'm going to suggest that we put all the small numbers in. One of the problems with putting all the small numbers in is this. You've got to do them right. And it takes time. So to save time, don't go away. I'm going to have all the numbers put in. Well, look at this. You know, I have to say something. My sweetheart Catherine was doing this puzzle. She picked up something that I hadn't seen. You know, you never know. It's what you see and when. Now, what do you do when you see this conglomerate of numbers? Well, here's some suggestions. Is there any possibility of a future matching pair? Well, maybe something there. There's a possibility here. There's a possibility up along here. I don't know. We'll have to wait and see. Is there a possibility of perhaps a 3 by 3? The 3 by 3 here's the 3 by 3 already, but you know, here's a possibility there too. But this is the most important thing, and I have got to get a habit, and you've got to get a habit of doing this. You look for what you call conjugate pairs. Now, a conjugate pair is any row, column or block that has a number that only appears twice. And I'll show you one. Here's one, a 7 and a 7. We call that a conjugate pair. If we were doing links, it would be something like, it would be a strong link. And matter of fact, I've got a list of these conjugate pairs that are used in so many things. They're used, I'll give you a list here where we are. Xwings, skyscrapers, empty rectangles, which I'm going to be covering soon, strong links, chains, X-chains, all kinds of techniques for advanced players can result if you understand the conjugate pair. Now, is there another one there? Let's have a look. Yeah, here's one here. There's a 7 there and a 7 there. One of the features of a conjugate pair is that if one is true, then the other one is going to be false. Or one is this becomes a 7, that will not be a 7. That's common sense. Is there anything else? So let me see. Here's one. Here's a 9 and a 9. They are the only two 9s in that column. So that would be a conjugate pair. Now, let's push on. Next thing I look for is something like where we can use the rule of exclusion. Now, let's take this block here. These two 9s are the only two 9s that can be in this block. Therefore, one of those must be a 9. We don't know which one, but one of them must be a 9. And what that means is the rule of exclusion is that you can get rid of this 9 over here. You can remove it. Okay, that's maybe simple, but look what I think it will do. Well, immediately it says that here we have a 9 that could be there or there. So you can't have a 9 there because in this row, 9 can only be there or there. If that's the case, you still can't have a 9 there. So there's another rationale for why you can't have a 9 there. Now, let's push on. I'm looking now again for conjugate pairs or a strong link. Yes, here's one here. Have a look at this column here. 9 only appears there and there. So that's a clue. Whenever you see that, you immediately say, oh, that could be something like an X-wing. And lo and behold, if you look across here, here is the same situation in this column. We have a 9 and a 9, and they make up a rectangle, which is in fact an X-wing. And I love X-wings because they help you get rid of lots of little numbers. Now, in an X-wing, if this is a 9, that's going to be a 9. If that becomes a 9, that's going to be a 9. That's the way X-wings work. One of the big features of this is it's a 9 on columns, which means that the rows can be, you can get rid of any 9 in the rows of this X-wing, providing they're not as part of the X-wing. Now let's have a look and see where they are. Well, here's one here. This is, which part of the X-wing? These are two part of the X. These are two part of the X-wings. So we can get rid of that 9, and we can get rid of that 9. Now that's in that row. Now let's go down to this row. We can get rid of any other 9s in this row that are not part of the X-wing. Well, this is part of the X-wing. That's not part of the X-wing. And that's not part of the X-wing. So you can get rid of all those 9s, and that really is going to help us, I hope. Let's have a look. If I look at this, now in this block there's only two 9s. One of those is going to be a 9. Let's see what happens if I try LCR. If this is a 9, I can go up. I can't go to there. I have to go to there. Then up here, that becomes a 9. Now, if this is a 9, and I do right, center, that becomes a 9 again. This 9 over here can't become a 9 because there's no 9 in here. For example, this 9, if it went over here, you still can't do it because that 9's gone. If this 9 went, say, up to here, it can't. They could go to there and get rid of that 9, but it can't. So this has to become a 9. So here we go. We'll get rid of that lot, and we finally got a big number, neato. Okay, now we'll make that a 9, and let's see what the ramifications are. We'll make this a 9, and immediately that 9 can go, because we discovered that we couldn't make that 9 work because there's no 9 in here. Now if that 9 becomes a 9, we've got rid of the 7 here, and remember we had a conjugate pair here. If that's a 9, this 7 must become the real 7. Okay, so that can go. That becomes a real 7. But there's also another reason why we can put a 7 in here. Have a look at this. When we got rid of this 9, you finish up with a 3 by 3. The 3 by 3, let me revise, 4, 5 and 6. Each one of these cells will either have a 4, a 5 or a 6. We don't know which cell will have a 4, 5 or 6, but that is a 3 by 3, and the rule with a 3 by 3 is this. Any 4, 5 or 6 in this row can be removed. Well, we have a 5, 6 here. So we can get rid of that 5, get rid of that 6, and now we still have a 7. So there were 2 reasons why we know that has to be a 7. Now let's look at the ramifications of that 7. First of all, this 7 goes. Secondly, this 7 goes. Okay? Now, what does that do? Let me see if I can clean that up a little bit. It's a bit bluish. Yeah. Okay. This is getting exciting now, just because we've discovered that X-wing in here. And maybe I should very briefly draw the X-wing in for you, just with dots, okay? There's 1 9, and this one went down. Just a minute, we'll go up here. Up to there. There's your X-wing. Now if you notice here, because we got rid of this 7, we have a 1 5 1 5 matching pair. What does that mean? It's very powerful. That means that any 1 5 in this block and any 1 or 5 in this column can be removed. Let's take these numbers in here. Here's a 5. Okay, I'll just get rid of that 5. And that becomes a 3. Great, here we go. If that, oops, a daisy. That 3, now this 3 goes, and this 5 goes, and this 3 goes, and this 5 goes, and we are left with a 4 7 matching pair. Whoa, another matching pair, which is great. I love matching pairs. Now, that's what we did with this block. But what about this column now? This 1 5 1 5 means that this 5 becomes a 6, because you can't have the 5 there. It becomes a 6. And so now we've got another number. We're starting to get some numbers now. Whoopee. Okay, now let's look at the ramifications of that 6. This 6 means that this here is removed, and this becomes a 9. So let's make that a 9. And that 9 now means that that goes, and this becomes a 4. Boom, 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 boom. Okay. That 4 means that this can't be a 4, and this can't be a 9. We've already got a 9, so it becomes a 5. So we've got that whole block just because we found this 7. Neat. That's exciting. Okay, now there's more things that we can do with this 6, I think. Yeah, look at this. See this 6 here? This 6 can go, and therefore this becomes a 4. Just clean it up a bit here. This becomes a 4. Now you can see, if you look ahead, you can see sort of things that can happen here, all kinds of things. Here we have a 4 and a 6, so this becomes a 9. If that becomes a 9, what are the ramifications of that? We've got to go through all the ramifications, so many new numbers. And this is the time when you're doing a puzzle where it's so easy to miss a ramification. You're probably seeing some more coming that I haven't got to yet. If that's a 9, This 4 has to go, and this 9 has to go, so this becomes a 6. Well, now we've got another block done. Now remember that if that is a 6 back up on that one. Let's go back to the 4. This 4 means that this becomes a 3. Okay? That's 3. Now this 3 means that this becomes a 6, because that was a new one, remember? You'd probably be saying, hey Robin, you missed it, ramifications on that 3. Oh, I'm getting there, just be patient. We'll get there. So that, whoops, that's not right. That was a 6, wasn't it? Okay, a 6. Now that 6, this 6 goes, and this 6 goes. Okay, well, and this 6 here goes. Oh, look at this. All kinds of eliminations are happening. Now, anything else here? This 6 down in here, what does that do? You've probably been yelling at me saying, whoa, you know, you missed this, you missed that. Well, I'm working on it. Okay, so this 6 means that this 6 can go, and this 6 can go. Now, and this 6 can go. Now, what does that do? That gives this a 9. If that is a 9, this has to be a 9. It's part of the X-wing. Okay, so we'll make this a 9. So that if that becomes a 9, because remember the X-wing was on the 9, that 9 goes, and this becomes a real 9. It's the rule of an X-wing. Okay, if that's a real 9, things are going to happen now. Okay, if this 6 here, continuing on with the 6, I'm looking for ramifications. This 6 means that this 6 can go. And this 9, 9, 9, 9, that's right. That 9 can go. Every time I do this, it's different. So this becomes a 5. Okay, now let's get rid of all the 5s that causes this. This 5 makes this a 4. Boom, 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 boom. If that's a 4, here we go with the matching pair. Do you see what's coming? This 4 means that this is a 7. And this is a 4. Matching pair always enables 2 numbers. If you get one, you get the other one. So that's a 4. Now if that's 7, well, let's deal with the ramifications. This is unbelievable, the number of ramifications we're getting. This 7 means that that 7 goes, and this becomes a 6. If that becomes a 6, and that 7 goes, that becomes a 5. So this becomes a 5. And if that's a 5, the 5, 6 is gone, so we get back to the 3s, top, bottom, middle. This has to become a 3, a big 3, which means that we can get rid of that 3 and this 3. All kinds of eliminations are happening now, and it's so easy to miss from. So for example, I've just suddenly noticed here, see this column here? This is supposed to be a 5 now. So we make that into a 5, okay, which means we can get rid of this 5 and this 5. And we're coming up, guess what, we've got another matching pair. Now let's see what happens on that one. If that's, let me look. So far we're doing all right. If we look at this row here, 9, 9, 9, that's the only 9 in this row, so this becomes a 9. Now I can see something happening here too. That becomes a 9. If that becomes a 9, we only have a 5 already here. You've probably been yelling at me for that one. That 5 means that the matching pair is going to work, so that becomes a 1, and this becomes a 5. This is exciting. Things are happening all because of the X-wing. Okay, now this is a 5, 5. We've got all that row done. We can get rid of this 5. We can get rid of that 5. So we're left with a 3 by 3 in here, a 1, 2, and a 7. That's going to be interesting. I wonder what's going to happen with that one. When we got this 5 here, we can get rid of that 5, and we can get rid of that 5. Now we have a 3 by 3. We have a 2, 4, and a 6 here. 2, 4, and a 6. Okay, let me see now. If that's a 9, and that's a 9, one of these is going to be a 9. We had a 5 down here. Look, I missed that. You probably saw that, and I didn't. It's easy to miss. His 5 means that this becomes a 9. Okay, if that becomes a 9, 9, 9, that fits. Okay, we can get rid of this 9 now. We have another matching pair. Woohoo! Okay, pushing right along. This 5 here means that this has to be a 5, and this over here, using LCR, left, center, right, this becomes a 5. Therefore, this 5 goes, and that 5 goes. Now, we've got a matching pair, 2, 6, 2, 6. Well, now we have a possibility of what you would call a danger, or a unique rectangle, and we've got to watch it, but you don't fall into that trap. Okay, fine. So let's push on. Down here we had a 4, so that 4 goes, and that 9 goes because we've got a 9. So this becomes a 6. Now, what is the ramification of that? Let's have a look. This 6 goes. So this becomes a 4. Wow. If that becomes a 4, this becomes a 6. The 4 takes it out, so it becomes a 6. Look at this. If that's a 6, this becomes a 2. That's a 2, which means that this can't be a 2. So that becomes a 6. Okay. And here we can't have a 6 now because we're a small 6. So this has to be, in this block, this has to be the 2. Okay? If that has to be the 2, and we've already got a 4 and a 6, which are these can go, this becomes a 7. Okay? I hope I'm not going too fast. I hope you can still follow me on this one, but this is looking good. Here we have a 2, 4. That's really a 4. We have a 2 and a 6. This 2 and a 6 here means that this becomes a 4. So this will make that a 4. I can see other things happening now, ramifications all over the place. Top, bottom, middle, yeah. This 6 means that this becomes a 5. Let's put that 5 in there. Because that's a matching pair, this has to become a 6. Okay, and we're getting close to the end, I think. So far, so good. Got my fingers crossed. Okay, now if this is a 7 here, and this is the 7 here, we need to have a 7 here. So that 2, 7 becomes a 7. Okay, and that 7 means that this now becomes a 1, because you can't have a little 7 there. That becomes a 1, and this becomes a 2. Okay, how are we doing now? Now this is interesting, because we had this is a 4, this becomes a 1. Because that's a 1, this becomes a 4. So that should do the trick, I think. Let's have a look. This 4 equals, this is a 1, and this is a 1, and this is a 4, 4, 4, 4, 1, 1, 1. Well, by George, we got it. That's so much fun, and thank you for sending me this puzzle. I hope you learned something from it. We found what we call a breakthrough. What do I mean by a breakthrough? A breakthrough is when you find a pattern such as our X-wing. Remember the X-wing was in here? Once we found that X-wing, all kinds of things started to happen. So next session, I'm going to give you a lot more details about the conjugate pairs, and more details about strong links and things like that. So that's it. Next session, we've got something brand new coming. Bye for now.